We cut some stuff, right? We put it on a plate. There are some things we should know. Somebody tell me, what is the sine of 180 degrees? 0. What is the cosine of 270 degrees? 0. What is the sine of 270 degrees? -1. All right. So our job yesterday was to leave here, and we should understand the patterns that every multiple of 90 is going to use the number 0 or 1 in some way as its x or y coordinate. The negative, positive part, we determine direction by where we are on the circle given that position. Okay? All right, I could have asked the question, what was the sine of pi? Okay, which is the same thing as asking you what's the sine of 180. So remember that 180 and pi, or 270 and 3 pi over 2, are both representations of the angle measurement, just given in a different way, or the position of the angle. And then the points, we would determine the sine and the cosine. Yeah. In just a minute. Okay? All right. The next thing that you guys did, we took a green circle. You cut things out to represent all the 45-degree reference angles, which means once you glued it onto your plate, you had a couple triangles here and a couple triangles here, right? Okay, so you have like this green triangle sitting here and here, here, and here. These 4 locations around our unit circle all represent locations that have a 45-degree reference angle. They're not all 45 degrees. One of them is. This one is. Okay? The others are different angle measurements, but again, they have that 45-degree reference angle. What I'd like you guys to do right now is to go around and at each angle label what the angle is in degrees, and then also label what it would be in radians. What will 45 degrees be in radians? Pi over 4. Okay? Yeah. Okay? And then remember, leave space, because we are eventually going to fill in a coordinate as well. Okay? So don't go up or down. Try and keep it going out towards the ruffly edges of your plate where you're not going to interfere with some of your other angles. Okay? Okay. The angle in the second quadrant that has a 45-degree reference angle is what in degrees? 135. Yeah, he's actually right. Okay, the angle in the third quadrant with reference angle of 45 degrees is 25. And in the fourth quadrant, 315. Okay, so that's usually not the part we struggle with. Part 1 that we struggle with is understanding relationship between degrees and radians. So getting our mind to think in that like a radian mode. Okay, and then we'll talk about the coordinates. So first of all, understand that every 45 degrees that you go is 1/4. Okay? So to 45 degrees is pi over 4, or 1/4 pi. Then 90 degrees is the next 45, which would make it 2/4, which is the same thing as 1/2, which is why you see pi over 2. So then another 45 would make it 3/4. Okay, yeah. So it's gone like 3 times. So this is 3 pi over 4. Another 45 would put you at 180, and you would have gone 4/4, which is just 1 pi. Okay. And then 45 past that would be 5/4. 45 past that would be 6/4, and 6/4 would reduce to 3 over 2. Okay. 45 past that would be 7/4. And 45 past that would be 8/4, and 8 over 4 would reduce to 2, which is why you see 2 pi here. So I'm pointing out this method because I want you guys to understand that once you know one relationship, you can memorize those other ones or have a good idea of where they fall. But if all else fails, you could go and count by fourths around your circle and get where you have to get rather quickly, as long as you understood the relationship that 1 pi over 4 was 45 degrees. Does that make sense? Okay. All right, so there's all of our radian measurements. All right, now, we said this was a unit circle, okay, which means this green part that you see extending right here from the center of the circle to a point on the circle is how long? 1 unit, right? This is 1. You guys don't have to write this part down, but just, okay, 1. turn your plates over on the back and look at the work we did yesterday. Yesterday on the back side, you guys already solved a 45, 45, 90 triangle that had a hypotenuse of 1, correct? Do you guys see that work on the back of your plate? The 45, 45, 90 with the hypotenuse of 1. If the hypotenuse was 1, what were the lengths of the legs? Rad 2 over 2. That means this is rad 2 over 2, and this is rad 2 over 2, which tells me the coordinates at this point are going to be rad 2 over 2, rad 2 over 2. Right? We already solved the triangle, correct? Now, let me ask you a question. What is the sine of 45 degrees? No. What is the sine of 45 degrees? Rad 2 over 2, because the sine is going to be the y-coordinate, and at a position of 45 degrees, the y-coordinate is rad 2 over 2. What is the cosine of 45 degrees? Rad 2 over 2. What is the tangent at 45 degrees? 1. The y divided by the x, because they're the same, 1. Right? All right, your job. Fill the rest of the coordinates in around your 45-degree reference angles. Now, the number parts aren't going to change, so I expect everybody's coordinates to include a root 2 over 2 and a root 2 over 2 for both the x and the y. But your position is changing, so what should change about your coordinates? The signs, negative and positives. All right, so go ahead and fill them in around your circle. Paper to make 30-degree angles. You start with 360. Fold it in half, and you have 180. Fold it in half again, and you have 90, but here's where you can't go and then fold it in half, okay? To turn 90 into marks that are 30 degrees apart, what would we want to do to our 90-degree angle? Into thirds. So, you know, kind of like when you're putting a letter in an envelope, how you like fold the top half so the bottom half is going to cover it, and it kind of like splits the paper into thirds. That's basically what we're doing here. So we want to fold in one side of it so that when I fold the other side, it will cover it. So I have like 3 little cone-shaped sections that are the same size. Does that make sense? It's a little bit difficult. It might not be perfect, but it's going to be okay. Okay, it just needs to be close to 30 degrees. We're not going to stress about the paper and the cutting, okay? There are greater things in life to stress about. All right? All right. After you've folded, just like last time, identify one of your creases as an x-axis. We're trying to cut reference angle triangles yet again, this time with a reference angle of 30 degrees. So from my x-axis, I'd like to cut the crease that's 30 degrees above, as well as 30 degrees below, and on the other side as well, so that when I put these on my plate, now don't freak out, perfectionist people. The orange triangles are going to cover the green triangles. It's okay. We use them for our purposes. You'll still see the tip of the green triangle sticking out to make your 45s green. So what's going to happen when you lay this down is this will mark your 30 degrees. Okay? Then you'll have one down here. So you'll have this orange triangle sitting here and here and on the other side as well. You to do exactly what we've done before. So at every position, we want the same information. We want what that position is in degrees as well as radians, and then we want to relate that to a coordinate pair. So right now, go ahead and go around to each of these positions and fill in the position in degrees as well as radians. What was 30 degrees in radians? Pi over 6, yeah. Okay, 6. Because it's got to be smaller than a fourth, right? Because a fourth would take you all the way to 45. So 30 degrees is a sixth, okay? And then eventually, yes, we're going to put an ordered pair here. If you're feeling exceptionally confident and you get all the resource that we've used and how they fit together, you can go ahead and fill in that pair. But my main concern right now that we'll check before we fill in the ordered pair is that you guys are able to fill in all of your angle measures in degrees as well as radians, okay? All right. Degree measures for your 30-degree angles. So, in degrees, 30 degrees, what are we over here? 150. So it's 30 degrees before 180. Okay, and then just after 180, 210. And right before 360, 330. Okay, those are pretty intuitive. We can figure it out because we understand how the 360 degrees work. Okay, so I told you counting by the 45s, counting by fourths, and that works pretty easy to get everything. 30s is a little more annoying in that world because there's a lot of 30s up there that we don't see that we'd have to count before we get to the next one. So I'm going to point out another way to do this, and you can see if this helps you. We know that 30s are sixths, okay? Some sort of sixth. So I'm going to use this as a reference point for me to just go above and below, all right? 180 degrees is at pi radians. If I had to think about pi radians in terms of sixths, it would be 6 pi over 6. Is that okay with everybody? That instead of calling this pi, I could call it 6 pi over 6 if I wanted to. Is that okay? And everyone probably thinks well, that's stupid because pi is so much easier to say. I agree with you, but if I'm trying to find out something else about these things that I know are all increments of 1/6, it helps me to think about this as 6 pi over 6. If I think about 180 as being 6 pi over 6, what is the sixth that comes right before 6 pi over 6? 5 pi over 6. Just showing you another way that you can establish where these are. What would be the sixth that comes right after 6 pi over 6? 7 pi over 6. And I can do the same thing over at 360. If 360 degrees is 2 pi, but I wanted to think about it in the world of being sixths, 2 pi is equal to how many sixths? A lot. How many exactly? 12 pi over 6. So what would this be that's right before I reach 12 pi over 6? This would be 11 pi over 6. Okay? I'm not saying you have to do it that way. I'm trying to give you a couple different perspectives of ways that I myself or I have seen students look at ways to figure out where radian locations are that make sense to them in the context of the circle. Okay? All right, now, in our orange triangles, this is our hypotenuse again, extending from a point on the circle to the center of the circle. And since this is a unit circle, how long is that hypotenuse? 1. Turn your plates over on the back side. What are the lengths of the legs of a 30, 60, 90 triangle that has a hypotenuse of 1? 1/2 and root 3 over 2. Now, here's the tricky part. It's not the same number, so you got to pay attention to where you put the 1/2 and where you put the root 3 over 2. Let me ask you guys this. What's bigger, 1/2 or root 3 over 2? Root 3 over 2. And in a triangle, smaller sides are across from smaller angles, and larger sides are across from larger angles. So if this is the 30-degree angle, across from it right here, is that the 1/2 or the root 3 over 2? The 1/2. It's the smaller side, the 1/2. So in our case, the 1/2 is this length. Is that an x coordinate or a y coordinate? The y. So it's 1/2, which makes the x, the longer leg, equal to root 3 over 2. Is this okay with everybody? So I'll be perfectly honest with you about my 30-degree angles. I know there's a root 3 over 2 and a 1/2 involved. I can't always remember which one's the x and which one's the y, but I just think about that little picture of that triangle, and I think about which one's longer and which one's shorter, the x or the y, and I put the number in its right spot based on what's smaller and what's bigger. Does that make sense? So you're either going to have to memorize the order and get it down, or you're going to have to be able to reason it out. Well, clearly in this triangle positioned this way, this is shorter and this is longer. So the x coordinate's bigger and the y coordinate's smaller. Okay? So for each of these triangles, they have that same setup, right? Long x with shorter y. So they're all going to be root 3 over 2, comma 1/2. You just got to get the negatives and positives in the right spot. So over here, it's a negative x and a positive y. In the third quadrant, they're both negative. And in the fourth quadrant, it's a positive x and a negative y. Okay, so again, you're cutting your yellow angle so that it's 2 of the 30s to make 60. So once you paste on your yellow triangles, they should look something like what you see up here. And the radians. So 60 degrees is how many radians? 1/3, okay? So 60 degrees is the same as pi over 3. Now, it's not that difficult to count by 60s. It's kind of like counting by 45s. 160 is pi over 3. The next 60 puts me right here at 120, and that would be 2 pi over 3s. Okay. The next one would put me at 180, and that would be 3 pi over 3s, which is just pi. The next one would be at 240, which would be at 4 pi over 3. The next one would be at 300, which would be at 5 pi over 3. And then that would take us back to 360, which would be 6 pi over 3. And 6 pi over 3 is the same thing as 2 pi. Okay? We'll label the coordinates tomorrow. If you're like, I got this, I totally know the relationship, then you could figure out the coordinates today. But we'll leave this for us to start with tomorrow. And then tomorrow we're going to ask a lot of questions. Like, what's the sine of 30 degrees? What's the cosine of 60 degrees? And all these things that we should now be able to figure out.